All right, in this example of a trigonometric identity, we're going to look at the strategy of making a common denominator. So looking at these two sides of my identity, I can see that the left-hand side is clearly more complicated than the right-hand side. The left-hand side just has two terms, it has fractions. The right-hand side is just down to one thing all by itself. So I know that I'm going to have to add these two fractions together since there's only one term on the right-hand side. So I get rid of the addition. So I have two fractions here that need to be added together. And when I'm adding fractions, I must have a common denominator. And right now I don't have a common denominator. So the first thing I'm going to do is I'm going to just multiply each fraction by the denominator of the other fraction. And that's because they have no factors in common. So if this had been cosine and this had been cosine squared, I might not have had to do that. But since they have nothing in common, I'm just going to multiply each one by the other denominator. So my first term is going to get multiplied by cosine over cosine. So that now it'll have a cosine in the denominator. And I'm just multiplying by 1. So that's okay. My second term is going to get multiplied by 1 plus sine over 1 plus sine. And again, I got what I'm multiplying by, these giant ones here, from the other term's denominator. And I'm still trying to decide if that is equal to secant theta. So far I've done no real trigonometry. All I've done is some fractions, just trying to get a common denominator. So now hopefully we remember that when we try to get when we're working to get common denominators, now we'll just multiply these together. So I'll have cosine times cosine is cosine squared. The denominator is 1 plus sine theta times cosine theta. The parentheses are very important here because if you didn't write the parentheses, it would look like just 1 plus only sine and cosine being multiplied. But cosine is multiplying this whole denominator, so the parentheses are extremely important here. Same over here, we'll have sine theta times 1 plus sine theta. So again, super important that we have the parentheses. And the denominator, which will be 1 plus sine theta times cosine theta. So now we have what we were looking for, which is a common denominator. Both denominators are 1 plus sine theta times cosine theta. Again, still haven't really done any trigonometry, still just doing our fractions. Okay, the next step when you're adding two fractions together is that you keep the denominator the same and you add the numerators. So I'm going to have cosine squared theta plus sine theta times 1 plus sine theta over cosine theta. Oh, I changed the order. Not important. Don't know why I just did that. It doesn't matter. I just rewrote these in the opposite order. Not a problem. And we're still seeing if that's equal to secant theta. Okay, so from here I want to simplify some things. So let's look up in the numerator. In the numerator, I have cosine squared theta plus sine theta times 1 plus sine theta. So order of operations that I should multiply these together before I can add anything. So I'm going to need to multiply these. As you can see, this is a sum. So when I multiply a constant by a sum, I need to use the distributive property. So I'm going to have to distribute sine here. All right, so now I will have in the numerator cosine squared theta plus sine theta times 1 is sine theta. Sine theta times sine theta is sine squared theta. And then in the denominator, I will have still cosine theta times 1 plus sine theta. And I'm trying to see if that is equal to secant theta. This point, this will be honestly the first time that we will actually use some trigonometry in this problem. If we look at our numerator, hopefully by now you're used to seeing the Pythagorean identity. We have cosine squared theta plus sine theta plus sine squared theta. And when you add, you don't have to add in this order. You can rearrange some things. So hopefully remember from our identity sheet, and it's maybe a tiny bit blurry, sine squared theta plus cosine squared theta is equal to 1. So when I see that I have this cosine squared theta and this sine squared theta here, I can add them together, and I can just get 1. So now my numerator is 1 plus sine theta, because this cosine squared and this sine squared just added up to be this 1. My denominator is still cosine theta times 1 plus sine theta. And we're still trying to see if that's equal to secant theta. So hopefully what we're noticing now is we have this sum 1 plus sine theta in the numerator, and we have 1 plus sine theta in the denominator. 1 plus sine theta over 1 plus sine theta makes a giant 1, since it's the same in the numerator and the denominator. That means we're left with cosine theta in the denominator. We'll need a 1 in the numerator. And we're still, is that equal to secant theta? Back to our formula sheet. Turns out that 1 over cosine theta is equal to secant theta. So now we have secant theta equals secant theta. We know this equal sign for sure now since we did it, and our proof is complete.